Okay, guys, the videos I promised you after exam. Exam scores are graded. The exams are graded and scores have been posted. The scores were okay. Some of you did really well. Some of you not as well. Remember, and I told you this first night of class, if you go back to your class syllabus, you have the option of replacing a lower exam 1 or exam 2 score as long as your final exam, if your final exam is higher. So let's say you had a bad night last Tuesday night and things didn't go as well as you had hoped. You still have hope if you've been coming to class. If you've missed really probably more than one time, considering that we haven't been in class that much because of the early snow, then you get to replace either exam 1 or exam 2 with a higher final exam score. So again, that exam score could be completely wiped out. And so, a lot of you did well, so good for you. But there were a few people, say I don't know, maybe 7, 8, or 9 that didn't do as well. So, but anyway, we're going on to other stuff. And what we're going to talk about today is we're going to continue with confidence intervals, but we're going to look at confidence intervals for percentages. So the first thing I want you to do is probably pause the video, log on to my stat lab, and if you come down here to course tools and open that up and come down, you'll see document sharing. So if you click that, you're going to see something that looks a screen that looks like what we're currently looking at. I uploaded a video. I uploaded a document for this video called "Handout for Video Confidence Intervals for Percentages." So if you open that up, again, pause, get it open, and come back and see me. Okay. So when you come back to see me, you're going to see a document like this, and the purpose here, this is a really good example of confidence intervals for percentages. And essentially what I'm going to do is kind of teach you the concept, and then we're going to apply the concept to this handout. So that's the game plan. Okay. So first thing I want to do is let me get some stuff going on my end. I've uploaded some notes here, and guys, remember, I think our agreement was we wouldn't stay after class after the exam, which is a good thing because a couple people didn't get finished until 10 after 7. But we agreed not to stay, and you guys agreed to watch the video, which you're obviously doing because you're hearing this. But you also agreed to turn in a page of notes. So what's going to happen Tuesday when we come into class, the first thing I wanted to ask you is, okay, turn in your page of notes that you took from watching this video. That's going to be a 100-point assignment that you'll see on my stat lab once I get these things graded. So anyway, guys, let's get it going. I'd like to keep this video as short as possible. So again, what we're studying here, we're looking at confidence intervals for percentages. Right now the problems that we work are going to be obvious. It's going to be confidence intervals for percentages. But when for example, let's fast forward here in about 2 or 3 weeks and you're taking your final exam, how do you know that this type of problem, that this is the tool that works this type of problem? Well, it's as simple as this. The problems are going to ask, what percentage, what fraction, what proportion of some population, in this case it's all Facebook users, update their status daily. Well, guys, I don't know about you, but I don't know the answer to that. In fact, I would suspect, I would probably say that no one does, and I would suspect anyone that claims that they do. So guys, previously our confidence interval problems were used to estimate an unknown mean. For example, what's the mean wait time for drive-through customers at Arby's or Tim Hortons? Well, I don't know. But these types of problems, which was trying to estimate a population mean, which is unknown, we saw depended on whether or not the population standard deviation was given or not given. Guys, when the population standard deviation was known, we used it. And the confidence interval formula we used, again, is called a z-interval. And you've seen that formula ad nauseum. When the population standard deviation is not known, well, we can't use it. So we have to use the sample standard deviation in replacement. When we use the sample standard deviation, we don't have as much information about the population. So we have to use a different distribution called the t-distribution to make our calculations for the t-interval. Well, guys, we're moving into a new type of problem, not where the mean is unknown, but where we have a population percentage that's unknown. Again, what percentage of Facebook users update their status daily? Now, I don't know that. That's an unknown value to me, and I'd say it is to most people. I'd say it is to everyone, to be honest with you. Okay, gang, the notation. Before we talked about population means, mu, but now we're talking about population proportions or percentages, and the notation we use for this is just p. The most confusing notation is the sample proportion. The sample proportion is a p with an upside down caret. We call that p hat. And p hat is something that we can actually calculate. We can go out in our population, randomly select n people, ask those n people whatever we're trying to estimate, bouncing it off the problem I used here, what percentage of you update your Facebook status daily. Those people who tell us that they update regularly would be our count. So for example, if we went out and sampled 100 people, that would be n. If 32 of those people tell us that they update their status daily, that would be 32. So our p hat would be 32 out of 100, or 0.32. So guys, at confidence intervals in general, what we start out with is we start out with something here called our point estimate. And believe it or not, we keep it kind of simple in this class. The only point estimates that we worry about are x bar, which would be used to estimate mu, or p hat, which would be used to estimate p. Both of these values right here, mu and p, remain unknown. We don't know the population mean. We don't know the population proportion. So we use these point estimates to make an estimate. But we know there's nothing special wholly about our sample, so we have to add and subtract margin of error. That's the part that happens over here on the right side. The critical value depends on the distribution that, our underlying probability distribution that models our problem. Our standard error is, a concept we talked about back in the central limit theorem. So guys, for our previous problems, again, we've used x bar plus or minus either z or t critical, and let's just write it as z critical in this situation, and take sigma divided by the square root of n. But we're moving into other problems, right? We want to take our sample proportion, use it to estimate p, and of course we want to build margin of error around this. Well guys, it turns out that the confidence interval formula for these types of problems is this ugly mess. So if we sought to get a 95% confidence interval, you should know by now that the Z critical is going to be plus or minus 1.96. Going back to the previous example where I said if we took a sample of 100 people and they told us that 32 out of the 100 said that they update their Facebook status daily, then our p-hat would be 0.32. Now, putting all this stuff together, we could calculate our confidence interval by taking 0.32 plus or minus 1.96 times the square root of 0.32 times 1 minus 0.32 all over n, which is 100. Guys, we can clean that up a little bit. So 0.32 plus or minus 1.96 times the square root of 0.32 times 0.68 over 100. Now the calculations that we'll make here, we'll go back to our calculator. I can't do that in my head. I don't know about you. So I would type in 0.32 minus 1.96 times the square root. Guys, if you need to slow down, just pause the video. Come back, I'll be here. 68 divided by 100. Hit the right arrow, close it down, and that's just perfect. Oh, I know what happened. I had put that in. I shouldn't put that in. Okay, now let's do it. This will work. Okay, that's kind of a nasty mess to put in, so it'd be nice if I could do something to simplify that. And it turns out I've got a key right down here above the enter that I'm circling over here. It says entry. Since it's a blue, I'll have to go second function entry. And what that'll do, that will bring the previous entry down to where I can edit. I don't like the way this calculator works, but I just downloaded this, so this is actually the first time I've used it. So anyway, I use the plus instead and hit enter. So guys, my confidence interval formula would be 22.9%. I can't put percentages in here. And then this bottom would be 41.1%. Okay? Now I'm going to get a big error there, but it's just I wanted to type that out just to show you what the confidence interval would look like. Don't forget, you got to put percentages in here. So if you were writing this up for an answer, this would be 22.9% and 41.1%. These are proportions, and obviously I multiplied by 100 to convert to percentage. All right, guys, let's work the problem. We'll get through this as quickly as possible. So this problem right here says a higher education administrator would like to use results from a recent survey to estimate what percentage of people SOS students owe more than $20,000, evidently in student debt. So upon tallying the results from a survey, it looks like they sampled 1,280 people, and they found that 448 owed $20,000 or more. So part A, the purpose is to construct a confidence interval to estimate the percentage. Okay, gang, keyword. Of college students who owe more than $20,000 for their undergraduate education. What type of interval should we use? Well, guys, this type of interval is called a 1 prop Z interval. That's going to become important because there's a calculator key on your calculator that makes this a lot easier. So again, one prop z interval is the name of the tool that we're using to work this problem. Part B, what proportion of the sample reported they had loans of more than 20,000? In other words, what's p hat? Well, guys, we know p hat is x over n, so x is the count out of the whole. So our p hat would be 448 divided by 1280. I'm going to grab my calculator here because I think that's points. Let's just be sure. Yeah, so 0.35. Okay, so this is 35% of our sample. Say I have student loan debt of more than 20,000. Now, part C, probably one of the most important questions. If you just really kind of find the statistics stuff kind of cool, which I don't know how many of you are going to jump on that boat right now, but if you think that, this is an important issue here, because I guess it's so important because people misuse it all the time. Anyway, let's think about this. A reporter for a university newspaper found this result online and wrote an article titled 35% of college students have more than $20,000 in student loans. Is this a correct statement? Absolutely not. It's a false statement. The 35%, the 0.35, which is obviously 35%, describes our sample. Simply the 1,280 students who took the survey. And if you put statistics on your radar and you start paying attention, you're going to see the media make this mistake all the time. I don't know what they just do. It's just something we have to get used to. Okay. So use the confidence interval formula, coming down to part D, use the confidence interval formula to construct a 95% confidence interval for the proportion, equivalently percentage, of all students who have $20,000 or more in student loan. Now guys, remember our p hat is 0.35. Our sample is 1280. So let's jump over to our calculator. And I knew it was going to get an error there. So let's start with the new screen. So I need 0.35 minus 1.96 times the square root of 0.35. Now guys, I'm going to do a little bit of mental math here, actually mental arithmetic. 1 minus 0.35, I can just see that that's 0.65. You know, if you can't, just stop the problem, get out, take 1 minus 0.35 and make a note of it. So my sample size is 1280. And hit enter. I need to do the same thing using a plus. We need some music or something, don't we? Wow. Okay. So that's 37.6. So guys, what do we got? 32.4% to 37.6%. So let's record the answer. So 32.4% to 37.6%. It is right? Yeah. Okay, guys, what's the margin of error? I'm still a firm believer the easiest way to find the margin of error is to take the big number minus the small number and divide all that by 2. And I'm just going to grab my other calculator here real quick and do that. And I get plus or minus 2.6%. Guys, remember, in doing your calculations, leave the plus and minus out of it, but include it, except on my stat lab. My stat lab doesn't want you to include the plus or minus, but include it typically in your answers. Okay, gang, interpretation of the interval. This isn't going to change from previous interpretation. We're just going to say there is a 0.95 probability, this interval. Contains P, which is the percentage of all students. I swear I can type. I swear I can spell. I just can't type. Which is the percentage of all students who owe $20,000 or more in student loans. Okay. Now here's the fun part. Use your calculator to verify the confidence interval. And you know, this is a way that you're going to perform most of your calculations. You know, when you log on to do your MyStatLab assignment this week and submit it Tuesday before class, many of these problems you're going to have the opportunity to you know, just plug the information in your calculator and go for it. So guys, keep in mind here, what do we have? We have 448 out of 1280. So 448 out of 1280. So the key to work these problems easier, just go to Stat and scroll all the way over to Test. And it's actually nearer the bottom than it is the top, so I usually just go to the bottom and scroll up. And you know, the name of this interval is called a 1-prop Z interval, which for my calculator it's located at A. It may be different for yours, and maybe the same. So guys, hit enter, and the first thing it asks us is X, which is the count, and we know that's 448. And the next thing it'll ask us to enter is the sample size, which is 1280. Confidence level, either 95 or 0.95. Do whatever suits your eye there. And hit calculate, and you're going to see that we get the same answers. Now, there are times that you may get a little different answer than your calculator, and this is just due to rounding. For example, if your p hat, you know, our p hat here turned out to be a nice, neat 0.35. But what if it was 0.35876? You know, had a string of decimals here. If we round off to 2 places or 3 places or 4 places, the more places we round, the less error that we get. But if we round to 2 places, the calculations done by the calculator and the calculations we do with the rounded answer may vary a little bit, but guys, they're not going to vary much. So the final problem. So this is done, and it's cool, right? Much easier than plugging and chugging that thing in your calculator. So the next thing, what sample size will reduce the margin of error to plus or minus 2%? Now I want to go back over here to Dulcery, to the chalkboard, if you will. Now, in these problems, the first thing you've got to remember is before you start any problem like this, you have to convert your percentage to a decimal. I mean, really, guys, you really look silly when you do mathematics with a percentage. You know, for example, go down to your bank and invest $10,000 at 3%. Do math with the 3%. Go down there a year later and say, hey, dude, where's my $30,000 interest? Well, you're going to look pretty silly because that's not the way we do math with percentages. We have to convert percentages to decimals first. And then you live in the real world and you'll go down and get your $300. So guys, same thing in this situation. You've got to convert your percentage to a decimal first, okay? So we talked about earlier that the margin of error for these problems, and actually this is plus minus the margin of error, is equal to plus minus the z critical times the square root p hat one minus p hat over n. And I tell you right now, again, these pluses and minuses, if you start working the problem like that, they're just going to get in the way. So anytime we're doing a calculation that deals with the margin of error, let's just use this. And guys, please pay attention to detail here. I had a student notice that the standard error here, that everything, all of this stuff is under the square root. I had a student a year or so ago that you know what, she just got sloppy, and when she was doing her notes in class, she wrote that down, and she couldn't understand why she was getting all of her answers wrong. Well, I mean, we got the wrong formula. It's not going to work. This square root, everything is under the square root. Okay? So guys, again, margin of error, the margin of error that we want here is 2%. And again, we got to use 0.02. Z critical is 1.96. Our p hat is 0.35. 1 minus p hat is 0.65. And the n we don't know. That's what we're trying to solve for. What n will reduce the margin of error to 2%? Well, guys, I think it's pretty clear that on the left side and the right side, the first thing that we're going to do here is divide both by 1.96. So that and that will disappear, leaving. Now, I'll go ahead and tell you, I'm going to go into some annoyingly fine detail here, but I want to do this to make a point. I want to do something that we can use. Hold on. We know the answer to that, don't we? That we can use for future help. Okay, guys, something else that should probably be pretty clear at this point, that we need to square both sides. Need to get rid of the radical sign on the right side. So the left side and then the right side is going to look like this. Now, this type of problem gives students difficulties from time to time because the variable that we're trying to solve for is in the denominator. But guys, I've shown you a trick that says if you have your variable in the denominator, you can switch things on the diagonals, right? And if you think about all of this just being over 1, then we can kind of look at all of this right here as being in our numerator. So if we can just switch those two, which is going to be really easy to do, our right side, our left side is going to be n over 1. And then this part over here is going to look like this. And let's go back and check that out. We're just bringing this entire dude right here. We're bringing it down here. Now, this thing over here, n over 1, you know, that's redundant. We don't need all that stuff over there. We don't need things under 1. Anything divided by 1 is just itself. So we have n. So, guys, if we can put this in our calculator without doing something insane, which we should be able to do, we're going to have our problem worked. So let's go back to the calculator. And I'm going to clear things out. So I need 0.35 times 0.65 divided by, and guys, I got to divide by the entire quantity, 0.02 divided by 1.96, and then I've got to square that. So I hit enter, and I get 2184.91. Now guys, you can't have 0.91 of a person, so sample sizes we always round up. So the answer to our problem will be 21, what was it, 21, this is crazy, 2185. So it's going to take 2,185 people to reduce the margin of error to 2%. Now, guys, that's a lot of algebra, and that's an algebra that would give some of you, drive you crazy when the stakes, stakes were high, like an examination or something. So what I want to do, I'm going to erase this. Guys, the answer is 2,185, right? But let's see if we can use the work that we've accomplished here to help us in future problems. I went through this annoyingly fine detail for this point right here. If you think about that 0.35 in general, what is that? Well, that was just our p hat. If you think about the 0.65 in general, what was that? That was our 1 minus p hat. If you think about the 0.02, what did that represent in this problem? That was the margin of error that we needed. And if you think about the 1.96, the role of that value in our problem is z star. So guys, for your next problem, if you're asked to find for a particular margin of error for a percentage problem, and you're asked to find the sample size that creates a particular margin of error, plug and chug. Put your p hat as a decimal in there. Take 1 minus p hat, put your answer there. Put your desired margin of error. Let's say we want a 5% margin of error. What are you going to do first? Change it to 0.05, and you're going to put it right there. Let's say we want a 90% confidence interval instead of a 95. Then you're going to put 1.645 as I showed you in class. So just enter the corresponding values in the proper places. Well, guys, that's the end of the video. I think I went over. Hopefully I didn't bore you too crazy. Couple of things. Remember, I've got a tight schedule the next 3 weeks. You need to get your butt in that seat, man. We got a lot to do, and it's just impossible. I know some of you are thinking, well, I can learn this at home on my own. The fact of the matter is you can't. I mean, you can learn some of it, but to do really well, just trust me. I kind of know what I'm doing with this stuff. So, guys, next 3 weeks, please get in class. So let's just talk again about our schedule. Next Tuesday, and I don't know, what is that? Let me pull up my calendar here real quick. There's my dog. So let's see, next Tuesday is, oh wow, it's tax day, right? Yeah. So April 15th, what should you do? Make sure that you get your My Stat Lab assignment turned in. Make sure you bring your page of notes from this video. Guys, that's worth 100 points. That's an easy 100 points too. And we're going to start something called hypothesis testing. You don't want to miss it. Okay. The Tuesday after that, this is, again, you'll have another My Stat Lab. This one will be on hypothesis testing. This is actually the last Tuesday of the regular term. You'll have your final exam study guide. And you're going to get your final project, which, by the way, is 10% of your final grade. You'll get your final project information. Okay? Next Tuesday, final exam. Guys, you can expect 30 questions, all multiple choice. You get to bring in 1 page of notes. Front and back, you can write anything you want to write. Finally, you'll be done with Darbro by Friday of finals week. By 5 o'clock p.m. Guys, don't hold me to this, but I think this is May 2nd. Your projects are due. All right, gang, have a good one. Sorry I went overboard on this one, but I did the best I could. See you Tuesday.